Thank you for joining this lesson. We're going to discuss vector 2. We are told that the position vectors of points A, B, and C are OA negative 5i, 4j plus 2k. Then the position vector of B, which is OB, is negative 3i plus 2j minus 2k. And OC, the position vector of C, is negative 2i plus j minus 4k respectively. Show that A, B, and C are collinear. So for us to show collinearity, we should show that two of the vectors within these points are parallel to one another and that they are sharing a common point. Therefore, we're going to express two vectors. Now that we have A, B, and C, we can have vector AB, which means we need to subtract A from B for us to know vector AB, because we have the position vector of A and that of B. Now we will take them as column vectors. We begin with B, which is a negative 3, 2, and negative 2. Negative 3, 2, and negative 2. Then we subtract the position vector of A as a column vector, negative 5, 4, 2. So this is going to be, this is a negative 3, this becomes a positive, so negative 3 plus 5 becomes 2. Then we go 2 minus 4, this becomes negative 2. Then we have negative 2 minus 2, that becomes a negative 4. So that is vector AB. We can do another vector like AC, like vector AC, whereby we need C minus A. This is going to be the position vector of C. Now that C is a negative 2, 1, negative 4, negative 2, 1, negative 4, then we subtract the position of A. That is going to be negative 5, 4, 2. Now this is going to be negative 2 plus 5. This becomes a 3. We have negative 1, negative 4. That becomes a negative 3. Yeah. Then we have negative 4 minus 2, which is to become a negative 6 now. A negative 6. So now with this, we can relate the two vectors, vector AB and vector AC. We can check whether vector AB can have a scalar multiple like k, which makes it AC. Then we compute and see the scalar multiple. Scalar multiple k, that multiplies negative 2, negative 4, so that we may get vector AC, which is 3, negative 3, negative 6. Now you discover the value of k is going to be, when we consider the y components, 2k will be equal to 3. That means the value of k will be 3 out of 2. That is 1.5. When we consider negative 2k equals to negative 3, again we will simplify and confirm k to be 1.5. When we have negative 4k equals to negative 6, we will again divide through by 4 and we will confirm the value of k to be negative, positive 1.5. Therefore, we can say that vector AC is equivalent to 1.5 vector AB. This means the two vectors AC vector is parallel to AB vector due to the presence of the scalar multiple, and A is a common point. since A is appearing in both vectors. Hence, now A, B, and C are collinear points. They are collinear points since two vectors are parallel due to the scalar multiple and that they have a common point. So that is how we show collinearity. Thank you for following. Subscribe and share.